can you reopen it because we may need it for questions. So, any questions to Ben? Okay, yeah, please.
What you mentioned that for biological models they're very huge, so it's not going to be processed as well. Is that something like here you have a very large molecule compared to what we've been using? What is like the extent? I guess you would know.
Don't ask me.
Do you know how big your molecule can get? It's going to get an optimal visualization back.
To the best of my knowledge, you take a single crystal, and you just solve it.
Okay.
And one thing I know, first of all, the compound has to be crystalline in order for it to be solved.
Okay.
Yeah.
Thank you.
There's also a lot of other factors. So, like whether a crystal will diffract X-rays or not. That's sort of experimentally. But my question is, can you generate a SID file based on no actual physical data? Like, let's say that you imagine a molecule. Can you build that, turn that into a SID file computational without touching any chemicals?
Computationally, I haven't done that before actually, so I think.
Well, I haven't done it before too, but it seems no problem. You take zip file of a correct structure and start modifying it. Well, I want to continue the first question because the answer was that one can process, one can convert into a zip file any single crystal material. But what is we may not understand in full, what is a crystal? And I want to give a prompt. What is periodicity? Like, is that periodicity a major feature of a single crystal? And maybe you can illustrate it with one of your slides. So please explain us the concept of periodicity, or your understanding of this concept.
Yeah, so from the best of my knowledge, I know there are types of structures. So you're gonna have the amorphous and crystalline structures. So amorphous, for one condition, which must be, of course, the one condition which your compound has to have in order for it to be solved. First of all, it has to be crystalline and not the amorphous. So if you meet that condition, then you are able, to solve the structure. And another one, as Joe said, it will depend if actually your crystal diffract. So you can have a crystal, but if it does not diffract, then you are not going to solve the crystal structure.
All correct, but maybe not comprehensive enough. We may a little more details. So what is crystal? Definition. So Ben was absolutely correct that in order to do X-ray diffraction and resolution of SIP, we need to have a crystal. But what is the difference between crystal and solution of some salt?
State of matter.
Huh?
Regularly repeated.
Do you hear what Joe told?
It was highly ordered.
Do you hear his second piece of wisdom? Can you illustrate it with your picture with Vesta file? Arrows.
Yeah. Yes. So like this one, actually, we have a strontium TiO3. So now this is the crystal structure of strontium TiO3, and Now, this one also, you are able to, from here, okay, you are able to determine that, okay, we have the strontium, you have the strontium, and then with titanium and oxygen, so this bonded together, and then these structures, as you can see, actually, this highly ordered, and can I say like in 3D dimension? Yeah, in 3 dimension. So you know.
Does everyone get it? So can you point on this little cube around one strontium? Yes. So you see a little cube structure, and then if you look to a neighboring piece of this structure, it looks exactly the same. So one can identify a small pattern and small piece that is exactly reproduced again and again. So it is maybe not very formal, but it is a definition of a crystal. So materials which are crystals are good. More questions to the speaker? If not, let's thank Ben once again. Oh.